Okay, so you have consider a triangle ABC with AB 4, BC 5, and CA 3. So let's draw a triangle real quick. So let's just say that it looks like this. Whoops. So we'll just make a triangle. There. And let's say that this is A, this is B, and this is C. So AB is 4, BC is 5, and CA is 3. Let D be the point of intersection of the bisector of angle A and the edge BC. Okay, so let's draw that. The bisector means to cut exactly in half, and angle A is right here. So this is angle A. So what we're saying is if we cut this angle in half, meaning that this side and this side are the same, then we want to find a D, right? So D is this point here where we've cut that in half. That makes sense? That's the setup. This is the point D. And we want to find A to D, so we want to find the length of this line. So one thing we know is that this is actually a right triangle. 3, 4, 5 is a right triangle, so I can draw one over here. Right, this would be a 3, 4, 5 triangle. I don't know if they taught you this yet, but you should know that this is a right angle. Right, so this 3 to 4 side corresponds to this 3 to 4 side. So this angle A is actually 90 degrees. That's something we need to know. Now, if you are not sure about that, you could use trigonometry to determine that. But we just know that since this is a 3, 4, 5, this is at 90 degrees. Which means that if we cut it exactly in half, we get two angles here and here that are 45 degrees. So this is 45 degrees. So now what we have is, let's actually look at on this one since I drew it to scale basically. We've cut this in half, and what we got is 45 degrees. So we have sort of two triangles now we could look at. One is the upper one, where this is 45 degrees, and this is unknown, and this is 4. The other one is the lower one, where we have 3, and this is unknown, and this is unknown. But what we got, actually, this is 45 degrees. We actually know some other stuff about these triangles. When this is a 3, 4, 5 triangle, this is also a 30, 60, 90 triangle. So that means that this angle is 30 degrees. And this angle here is 60 degrees. So if you want, I can make another video showing how we know about this triangle like this, but now we can basically solve this because what we have are other pieces of information. So we know that this is the 30 degrees. And so what we could say, right, we want to find this side. Let's call it AD. We're going to ignore the other one because I'm just going to use this left one. So we need to use law of sines now, is what we could do. Because the law of sines says that if I have angle A over the sine of, side A over the sine of angle A is equal to side B over the sine of angle B. And you could do this for side C as well, but we're not going to need to do that because what we have is, if this is 30 and this is 45, we can find the missing angle here and complete this triangle. Right, 180 minus 30 minus 45 will give us that other angle. So that would be 150 minus 40 would be 110, minus 5 would be 105. So this angle here is 105, which means that we can now use this equation. So we know that 4 over the sine of 105 degrees, right, this is all in degrees, is equal to AD over the angle that's across from it, right? So there's this angle that's across from it, which is 30 degrees. So we can say sine of 30 degrees. So AD. So what we can do is multiply this over, right? And grab that and move it. Whoops. Why can't I move this? There we go. We can just multiply it, basically, right? Because it was on the denominator. Clean this up a little bit. So now what we have is this equation. Sorry, it's a little bit messy. So sine of 30 times 4 over sine of 105 is AD, which is what we're looking for. So if we use our calculator, let's use our calculator. Let me plug that in. So first we need to make sure we're in degree mode. So let's just make sure that's true. So I'm in my calculator right now. You can't see this, but I'm going to change my mode to degree. And then what we're going to do is we're going to type in this sine of 30 times 4 divided by this sine of 105. And my calculator gives me some funky expression, but if I tell it to give me a decimal, it tells me it's 2.07. So this comes out on my calculator 2.07.